All right, this is the review for 6.1 and 6.2. So we're going to start with some transformations of exponential functions. So our parent function here is going to be y equals b to the x. Okay, and then our transformations that we can tack onto it, we can do a times b, and instead of x, we can have x minus h, and then we can have a plus k at the end. Okay, so a is going to be your vertical shift. I'm sorry, your vertical stretch or your vertical shrink, right? Vertical stretch or compression. H is going to be your horizontal shift, and then K here is going to be your vertical shift. Right, so if we look over here, A is 2. Since A is bigger than 1, or the absolute value of A is bigger than 1, this is going to be a vertical stretch by a factor of 2. Right, and then we have a plus 2 here. Right, so remember it's x minus h, so x plus 2 is really x minus negative 2. So this is going to be a horizontal shift 2 to the left. Right, and then we have this minus 6 here, which is my k value. So that means we have a vertical shift 6 down. Vertical shift down 6. All right, so we have the A, the H, and the K. The A here is telling us it's gonna be vertical stretch by a factor of 2. The minus 2 here, or x plus 2 is really x minus negative 2. So we switch the sign and go left 2, and then down 6. All right, over here, parent function is going to be y equals 2 to the x. And then we have an a value of -4, an h value of 3, and a k value of 7. So our a value actually here tells us 2 things because it's also negative. So first thing is that this is a vertical stretch. And that's because the absolute value of a is bigger than 1, right? 4 is a larger number than 1. By a factor of 4. Okay, but it's also going to tell us that it's reflected across the x-axis because it's negative. That means it's getting flipped down across the x-axis. Okay, so the -4 tells us it's flipped down because it's negative. It's a stretch because the absolute value of -4 is 4, and 4 is bigger than 1. Right, that 3 there. So we're going to go 3 to the right. So we're going to have a horizontal shift 3 units to the right. So right 3. And then plus 7 here. So we have a vertical shift up 7. All right, it's going to go 3 right, up 7, and it's going to get stretched and flipped over the x-axis. 4 different things happening there from our parent function 2 to the x. All right, number 2, we're going to have the same functions. We're going to graph them, though. All right, so... All right, so the first one, h of x equals 2 to the 0.5, or times 0.5 to the x plus 2, and then minus 6. So this is going to be exponential to k because our b value here is less than 1. It's between -1 and 1. So it will be exponential to k. First thing we're going to do is we're going to look for a k value, and we do have a k value. Okay, this means my asymptote, okay, is going to be, and maybe I should fill this in as we go, might be smart. Let me see if I can zoom out. Yep. Okay, so our asymptote is going to be y equals -6. Right, so our k value means we got shifted down 6. So everything 1, 2, 3, 4, 5, 6. Usually your asymptote is at y equals 0. right? If there's no k value, it's at y equals 0, but it's getting shifted down 6. So our asymptote is y equals -6. Okay, next thing we're gonna do is we're gonna find our y-intercept. So I'm going to use a different color, make a little table. Okay, I'm gonna plug in 0 for x. Okay, and I can use my calculator for this. So add calculator. Okay, I'm gonna do 2 times, in parentheses, 0.5 to the, instead of x plus 2, I'm gonna do 0 plus 2. And then -6. I hit enter, and I'm gonna get -5.5. That makes sense. That's 1/4, that's half. Minus, yep, that's good. Okay, since this is decreasing, I'm gonna pick a negative value for x next. So I'm gonna highlight it, and instead of 0, I'm gonna do, let's say, -2. I get -4. So I also have a point at -2, -4. So I have 0, 5.5. Then I have -2, -4. That's all I really need, but I'm gonna put in a couple more numbers just to, make sure I'm doing it right, I'm gonna put in a -4 maybe. Okay, and I get 2. All right, so it's gonna look, it's gonna come down. And it's gonna look something like this. It's gonna approach y equals -6, but never touch it. All right, there's my graph. All right, so my domain, we're going all the way left, all the way right. So there's my domain. -infinity to infinity. Range, the lowest I can go is -6. Well, I can't quite reach -6, but I approach -6. And then the highest I can go is up towards infinity. I can't reach infinity, but I can get close. Or I approach it. I don't really get close, I just approach it. So we use parentheses. End behavior, as I go to the right. Okay. As this graph goes to the right, we're approaching -6. As this graph goes to the left, we're going up towards infinity. So as we go to the right, we go towards -6. As we go left, we go towards upwards towards infinity. And then we said our y-intercept was 0, -5.5. All right, wonderful. Next one. +7, right? So that means our asymptote 1, 2, 3, 4, 5, 6, 7 is right here at y equals 7 because our graph got shifted up 7 units. So my asymptote is y equals 7. All right, next step, I'm gonna find make a little table, x, y. Okay, I'm gonna plug in 0 for x. So if I pull up my calculator, I'm gonna have -4 times 2 to the 0 minus 3. And then +7. I get 13 over 2. If I hit Control Enter, 6.5. So let's see, 0, 6.5. Okay, let me get one more point. So I'm gonna plug in maybe a 2. So instead of 0, I'm gonna put a 2. And I get 2.5. And just to get one more point, maybe I'll do a 4. I get 4, -1. So I have 4, -1, I have 2, 5, and I have 0, 6.5. Right, so we're gonna get close, but not touch. And then we're gonna come this way. We're gonna grow more negative like such. Okay, so there is our graph. Again, our domain is negative infinity to infinity. We can go all the way left. We can go all the way right. Range, the lowest we can go is negative infinity, or we can't really reach a negative infinity, but we can approach negative infinity. And then the highest we can go is approaching 7. You can't quite reach 7, so I'm going to put a parenthesis instead of a bracket. And behavior as x goes to the right, this graph is going down towards negative infinity. Okay, as x goes to the left, right, our graph is approaching 7. Again, not quite reaching it, but approaching it. And then our y-intercept was 0, comma, 6.5. Right, and there's your two graphs. Right, number 3. Determine if the following equation represents exponential growth or exponential decay. So the way we're going to determine that is by figuring out what b is. So again, here's our equation, a times b to the x. You could even add the minus h and plus k if you want. But the key here is the b. Okay? If b, the absolute value of b, is greater than 1, then it's going to be exponential growth. If the absolute value of b is less than 1, then it's going to be decay. Okay, so the first one is exponential growth. Because b equals 7.2, which is greater than 1. Okay, this one over here is exponential decay because b equals 0.26, which is less than 1. All right, wonderful. So next up, find the increase or decrease rate percentage. So we want this as a percentage from the following equations. All right, so this is our growth factor. So I'm going to split this up into 3 times 1 plus 0.7 to the x. Okay, what this means is our growth rate is 0.7. And if we write that as a percentage, that's going to be, move the decimal over twice, that's going to be 70%. Okay, remember 70% is going to be 0.7. 7% is going to be 0.07. And then 0.7% is 0.007. 007. All right. Got to move the decimal over 2 spots. Okay, B. This one's a little trickier because this is exponential decay. Again, we know it's k because the absolute value of b is less than 1. I'm going to split the growth factor up into 1 minus, right, something to the x. Okay, if we want to figure that out, 1 minus r equals 0.087. So if I subtract 1 from both sides, I get negative r equals, and then we could use our calculator if we want to or need to, So we would do 0.087 minus 1. Right? Okay. And we get negative 0.913. You multiply by negative 1 on each side, you get 0.0913. Okay, so what that means is in order to get this decay factor, we need to do 1 minus 0.913, which means we are decreasing by 91.3%. Right, this is 8.7%. Right, so to get 8.7%, you got to do 100% minus 91.3%. All right, next one, you got 3, and then again, we can split this into 1 plus 5.4. And then 5.4, you got to move the decimal over twice. You're going to get 540%, right? 5.4 is 540%. All right, next one up. Y equals 62. 0.72. Sorry, 1 minus, this is exponential k. 1 minus something, right? So 1 minus r is going to give us 0.72. That's going to be 28. But if we need to solve, we'll subtract 1 on both sides. You get negative r equals negative 0.28. And then you get r equals 0.28. Which means 28%. It's a decrease of 28%. Good. All right, the rest is 6.2 here, where we just have different types of interest questions. So number 5, a gym is increasing its members by 3% per month. If the gym currently has 3,950 members, what would be the approximate member count in 13 months? So we're going by monthly, right? Oh, so this one's per month. Okay, so they make it a little more challenging. Okay, so we're just going to use the standard exponential growth for this one. Right, so we're going to do A equals, okay, our initial amount, which is 3,950. Okay, and then we have 1 plus our rate, which is going to be 0.03, right? 3% written as a decimal is 0.03. Okay, and then it's going to be to the 13th. Okay, the reason this is just the simple exponential model is because it's not 3% per year over 13 months, it's 3% per month for 13 months. So we can just use the standard exponential function there. Okay, from there we can just put that in our calculator. So let me pull up my calculator. All right, so we have 3,950. And then in parentheses, we have 1.03 or 1, you could even do 1 plus 0.03 to the 13th power. And we hit enter, and we get $5,800.71. So A equals $5,800.71. Perfect. Okay, the next one. A new computer costs $950. The computer decreases in value by 20% annually. Okay, what is the computer's value after 5 years? So we're gonna again use the simple one. Right, so I'm gonna start at $950. Okay, I'm gonna do 1 minus, it goes down by 20% each year. That's 1 minus 0.20. And then over 5 years. So that's gonna be 950. And then that's gonna be 0.8 to the fifth. And the answer we get for that, if we put it in our calculator, is 950. I always just put 0.8 to the fifth power. We get $311 and 30 cents. $311.30. 311.30. That 29 gets rounded up to a 30. All right, good. Okay, next up. How much money will you have in 17 years if you invest $6,200 at 2.5% compounded quarterly? So since it's compounded quarterly, and our interest rate 2.5% per year, we're using the second formula. So if I were to clear this, we're using this one right here. All right, so we have an initial amount of 6,200. 1 plus R over N, so this is going to be 0.025 over N, which is 4 because it's compounded quarterly. And then to the NT, which is 4 times 17. So we can put that all straight in our calculator again. We're going to have 6,200. 1 plus 0.025 all over 4 to the 4 times 17. Enter. $9,470 and 93 cents. And there's number 7. All right, number 8. Okay, compounded monthly here. So we're going to start with $1,370. 1 plus our rate is 0.06 divided by monthly, so that's a 12. And to the NT, so that's going to be 12 times 6. Again, we're just going to put that in our calculator. So I have 1370. 1 plus 0.06 all over 12. And then we're going to raise it to the 12 times 6 power. And we get $1,961.90. So $1,960.90, right? $61. Good. Okay, the next one here is compounded continuously. Since it's compounded continuously, we have to use the final equation here, A equals P e to the RT. All right, so we have A equals the initial amount, which is 300. E, and then as 0.11, and then T is going to be times 8. So we can put that again, just right in our calculators. 300. E is right down here, and that's 0.11 times 8 years. Right, it was 8 years, yes. Enter. That's going to be equal to $723.27. Awesome. The last one here, again, compounded continuously, so we're using the same formula. So we're going to invest $26,000 this time. Annual interest rate of 2% compounded continuously. Calculate the final amount after 23 years. So we're going to do E times 0.02 times 23. And we can put that in our calculator. So 26,000 E to the 0.02 times 23. And we get a final answer of $41,185.90. And that's it.